Module 8 is on inverse functions, and we have two worked examples to go through. In our first one, we want to find the inverse function of the following function, f of x equals x plus 2 all squared. And we're given a restriction on the values of x. We want x to be less than or equal to minus 2. This is quite common when you're dealing with functions and their inverses. The point being that the function x plus 2 all squared doesn't actually have an inverse function, but if we restrict the domain to only values less than or equal to minus 2, then we do get an inverse function. So we have to find the inverse function and then do a few other things. We have to specify the domain of the inverse function, and then we need to sketch this function, x plus 2 all squared, and the inverse that we calculate. Okay, so there's a standard procedure for finding inverse functions, and we're going to do that to solve the first part of this question. So we set y is equal to the function, and then solve for x, right? So this is the standard procedure, as I assume you know. So we'll start by doing that. So set y to be x plus 2 all squared, and solve for x, right? This is the first part of this standard procedure to finding an inverse function. Okay, so away we go. So if we've got y is equal to x plus 2 all squared, then this implies, so how do we get x by itself, right? Well, the first thing we want to do is get rid of that squared. So we want to take a square root. So let's take the square root of both sides. So this implies that the square root of y is equal to x plus 2. But whenever we take a square root, we can have plus or minus values, right? So we actually get two potential functions here. We could get negative square root of y is equal to x plus 2. Remember, we're trying to solve for x, so just take the 2 across to the other side. So we get x is equal to positive square root of y minus 2, or we could have x is the negative square root of y minus 2. So there's two potential inverse functions, and we have to figure out which one do we want. And it all comes down to specifying that x had to be less than or equal to minus 2. That we can use that to tell us which of these potential inverse functions we need. So let me write that the inverse function using the f notation is f inverse of x is equal to square root of x minus 2, right? We replace the y's by x, or f inverse of x is equal to negative square root of x minus 2. So how are we going to pick which one it is? Well, we're going to think about the range of the inverse function. Because remember that the domain of a function is equal to the range of its inverse, and vice versa. The range of a function is equal to the domain of its inverse. Now we know the domain of our function. We're told it explicitly in the question. We need the domain of this function is all values of x less than or equal to minus 2. So that's going to be the range of our inverse function. So when we look at these two potential candidates for our inverse, which function is going to have values less than or equal to minus 2? Well, we both have the minus 2 part, but if we want to make it less than or equal to minus 2, we're going to take this negative square root. Right? If you think about putting values of x in that make sense into this equation, we'll get values less than or equal to minus 2. Okay? So that's the inverse we're after. So since the range of f inverse of x is the domain of f of x, and we know the domain of f of x is less than or equal to 2, we have range of f inverse of x equal to all values less than or equal to 2, which I'll write using interval notation, minus infinity up to 2, and we're allowed to include 2 because it's less than or equal to 2, so we use a square bracket. And as I explained on the previous slide, this meant that we must take our inverse function to be minus root x minus 2, because this function here will produce values, potential values bigger than 2. So our inverse function is f inverse of x is minus the square root of x minus 2. Okay, so that's just the first part of the question. We were asked a few other things. So we also want to specify the domain of the inverse function now that we have it. And we've already talked about that. Remember, the domain of the inverse is the range of the function. And we want to sketch the function and its inverse. So while we have the question up, let's think about the range of this function f. So here's our function, x plus 2 all squared. So we're squaring something, so we're only going to get positive values out of this function. We can get 0, because if you put x equals minus 2 in, you get 0 squared, so 0. But then any other value of x you put in, we're just going to get something positive. So the range of the function f is everything bigger than or equal to 0, and so that's our domain of our inverse function. Okay, so the range of f of x, which was x plus 2 all squared, is everything bigger than or equal to 0. So square bracket 0 up to infinity. And so this becomes the domain. Theory tells us this. So the domain of f inverse is everything bigger than or equal to 0. And now the last thing we had to do was sketch the function f, the original function f, and its inverse. And to do this, you could treat these two functions separately and think about how to graph them. But what I'm going to do is remember that if we want to graph an inverse function, we graph the original function and then flip it about the line y equals x. Okay, so let's think about the original function, which is x plus 2 all squared. So this is a parabola, right? If I expanded this out, I'd get a quadratic. So we know the graph is a parabola. But it's nicely factored for us, and it makes it easy to graph. So remember that the roots of this equation will be x equals minus 2. That's when we get values of 0. So it's a parabola that touches the x-axis at minus 2. And it's positive, right? We only get positive values. So the graph of f of x will be this parabola. It touches there, and then I'm going to do this side dotted, because remember that actually we restricted the domain of f of x, right? So remember, we were after f of x equals x plus 2 all squared, but only when x was less than or equal to minus 2. So we're actually just this half left-hand side of the parabola is the graph of f. Okay, so what about the graph of the inverse function, which is this thing here? Well, I'm going to use the method of reflecting about the line y equals x. So we've got this straight line at 45 degrees. All right, here's my y equals x. And now we're going to reflect the blue graph about y equals x, and we'll get the following. So this point minus 2, 0 will come flip down to be 0 minus 2, and we'll get a parabola down here. So this, and it goes on forever, obviously. This is our inverse function, which is minus root x minus 2. And so that's the sketch of f and its inverse, minus root x minus 2.